Good afternoon, everyone. On Monday, we talked about the first example in optimization model. We talked about elements of optimization model. Have you guys had the chance to watch the video of the class that I uploaded in Box?
I have not watched it.
Okay. Yeah, please try to watch after each class. I upload the class recording. Please make sure to watch the videos because I do not lecture the same thing every day because we cannot cover all the examples. We want to, there is a lot of examples in chapter 14, 15. And this way we won't be able to cover all these examples. So please make sure to watch the previous videos. So just to refresh your mind for optimization, we have these four elements: objective variable, decision variable, we have constraints, and we have input variables. Objective variable is the one that we want to maximize. We want to optimize, maximize or minimize. You know that I always use this example. When you profit equals revenue minus cost. Okay. We want to maximize profit through minimizing cost or maximizing revenue, or both of them. Okay. That's all we want to do. In all these examples you will find something like this. But our job here as a data analyst to identify the elements of cost, revenue, and how to form the profit margin and this kind of stuff. So here's the objective variable. We want to maximize or minimize it depending on the variable that we want to use. Decision variable is the variable that is in our control. We can change its values to be able to maximize or minimize the objective. So the decision objective variable must be connected to the decision variable, but the decision variable must be allowed to change freely. We let the Excel or Solver add in changes its value to come up with the best value for the objective variable. It may be a little confusing, but I will show you with an example. And we have some constraints that should be met. Constraints like labor hours should be no more than the labor hours available. For example, we have 2 employees, and each employee they work 8 hours a day. So we have total of 2 times 8 was 16 labor hours. Okay? So 16 labor hours. So in our planning, programming, and etc., the labors used must be less than or equal to the 16 labor hours. This is one constraint. Okay? And we have some input variables. For example, the costs of, for example, for each hour an employee might get, for example, $10. This is a kind of input variable. So our job as a data analyst is to first identify these variables. And then we give, after identifying these variables and setting the values for these variables in Excel, we develop an Excel form in Solver. And Solver tries to find the best values for the decision variable. This is model development, running Solver, and the third step is going to be the sensitivity analysis. So in optimization, first we develop our model by identifying these variables. Second is to run solver to find optimal values for the decision variable to be able to maximize or minimize the objective variable. The third step is called sensitivity analysis. By sensitivity analysis, I mean you want to change some values of these variables, constraints, and also the objective function. We want to change the values to see how sensitive our data is to those changes. In sensitivity analysis, we can change two values. For objective function, we have C1 x1 plus, this is the algebraic equation of this objective function, C2 x2 plus Cn xn. Here is our objective function. This number n1 through n, these are the number of decision variables. Number of decision variables. We can change these coefficients. In one sensitivity analysis, one type of sensitivity analysis, we change one or more coefficients in the objective function to see how our equation changes. The other method is to change the values in the constraint equation. In constraints, we have A1, x1, A2, x2 plus A1, x1 must be to the equals, less than, or greater than E n. Okay. Like the constraint that I mentioned for the labor hours. We have 16 hours. We try to change that B. By changing this value, we want to, for example, we change the value of the available labor hours from 16 to 18 to see how our equation changes. Because those decision makers and strategists, they need to predict some variation in the future. There is no absolute answer to one question. We have to assume all these changes. So in sensitivity analysis, we change this coefficient in the objective function and this one for the constraint variable. This is the objective function and this one is for the constraint. Here you see this table. I've already uploaded the solution to the first example of chapter 13. Class recording example 31. Here's the completed example for example 13.1. Okay. In that example, this one number of computers to produce basic and XP. Do you guys know the story of this example? Yeah. If you don't know, please take a few minutes to read that example in your book, in your textbook. Do you guys have your textbook or access to this online version? Okay, yeah.
Your age.
Example 13.1. Let me put it on the screen. Example 602. 603. Just read this example and take a look at this one for a few minutes to see what is this question all about. PC Tech is a company that produces two products, X1 and X2. X1 or basic and X2. It produces X1 and X2. Okay. So we want to objective is to find the best mix of computer models to see company level availability and etc. To maximize, the objective is to maximize the profit. As I said, we use this formula. Profit equals revenue minus cost. Okay. This company produces these two types of computers. We want to know how many of each of these two computers to produce to be able to maximize the profit. So we have cost, we know the same values for each computer. We have some constraints and we have some cost elements. We have component, we have some computer parts, and we have testing cost, and we have assembly cost. First, we need to calculate these elements and then subtract it from the revenue or the sale value of a computer to be able to maximize the profit. Our decision variables will be these two elements. We want to see how many of each of these two computers to produce to be able to reach the maximum profit. That's all we need to do with this example. You can find its solution from this file. Cost per hour assembly is $11. Cost per labor hour testing is $15. These are the input variables. Along with these variables, these are the input variables. For example, for basic or XP computer, labor hours for assembly, it needs 5 hours, labor hours for testing, and etc. These are the input variables. We have to determine numbers to produce, which is the decision variable, and the objective is here, the maximum profit. And then we need to define these variables here. Here is the objective variable. In maximum, we want to maximize the profit. We want to maximize the objective variable. If it was cost, we would have to click the minimum because we needed to minimize the cost. This is the decision variable, and this box is where we define our constraints. And here we check this box for the non-negativity constraint, and we use simplex linear program. And then click solve, and after click, we get these results for the numbers to produce, and with the maximum save of this one. So for the sensitivity report, we get these values. Again, this upper diagram, it shows the allowable increase and decrease for the number to produce for the first item, and this is for the second item. For example, this one, allowable increase and allowable decrease, which means for X1 we can produce between 0 and 80 plus 27 to be 108.5. Allowable decrease, 80 minus 80 is going to be 0. Allowable increase is going to be 80 plus 27, 107. That means if we produce between 0 and 107 of X1, our profit is not going to change. Okay? That's what it means. And the same for the second item, allowable increase and decrease. For the lower part of the sensitivity analysis, it changes these equations. It changes the constraints, not objective variable. Changes these limits. For example, constraints for the assembly hours. Here we have constraint. These are two constraints. It changes these values. For example, if hours available changes from 10,000 to 12,000 to 12,000 hours, what's going to happen to our profit? So instead of changing the objective, it works with our limits and constraints. And here you see this value. And shadow price, it means if you change by changing 1 unit of EN, the company must spend $16. That's what it means. Shadow price means by changing or by increasing or decreasing. By decreasing the B with 1 unit, then the company must spend more or less $16. That's the interpretation of shadow price. This lower table changes these values, our limits, for example, from 10,000 to 12,000. Let's see what its allowable increase is, 200. So this must change between 10,000 plus 200. And allowable decrease is to 87. It means our hours available must change between these two values. If this value goes beyond this one, for example, if it is 13, for each unit increase, the company must pay $16. It's a little confusing, but you should go on and practice this equation and see what this example is all about. That's the interpretation of this result. Allowable increase, allowable decrease. This is for the assembly hours. This is the allowed range. If we, for example, change it 10,000 to 201, the company must pay $16 more to produce those components. So we work with the constraint and the objective function to see how our equation changes and get some sense of the problem. And shadow price is very important. You need to spend $16 more or less. So now let's go to the other example, to the extended version of this example. Solver sensitivity. Two variable, multiple variable. Okay. Let's take a look at this example. This is an extended version of this example. In this example, we have two variables, but in the second example, producing computer at PC Tech, example 13.2, instead of two variables, we will have 8 variables, multiple variables. So the logic is going to be the same as the first one, but we have multiple variables with 2 production lines. Let's take a look at this example for a couple of minutes. All right, in this example, which is an extended version of the first one, we have 8 variables or 8 products instead of 2, and we have 2 production lines. These are the difference between these two examples. So in order to calculate the unit margin, first we need to calculate selling price. We have all these data available, and we need to subtract these three elements: labor hours per unit, cost per labor hour, cost for components, and subtract these three elements from the selling price. We need to subtract the cost from our revenue to form our unit margin. And we have some constraints. For example, labor hours used must be less than or equal to labor hours available. And total computers produced must be less than or equal to the maximum sales, maximum capacity of that company. We have this data in this example. You can get download this information from chapter 13 module. I uploaded this data in chapter 13 data file. Please download these files and try to solve this problem with me. Okay, for this example, first we need to identify our variables. We have some input variables. These three, and these are the input variables. What could be the objective variable? What are we going to maximize or minimize in this example?
Maximizing profit.
Yes, maximum profit here. The net profit here. Here we calculate the total, and this cell is going to be our objective variable. We color it red or orange. We have two decision variables, numbers tested on line 1 and number tested on line 2. These two are going to be our decision variables. So we have input variables in blue, decision variables in green, and objective variable in orange. And we have some constraints. You see here, hours used must be less than or equal to the one, and the other constraint is that total computers produced must be less than or equal to the maximum sales. This is going to be our second constraint. Now we have identified our variables: objective, constraint, decision, and input variables. The next step is to connect these variables with the decision variable. You know that these decision variables must be allowed to change freely. So we are not allowed to enter any formula or anything in this for this variable. So we have to connect our input variable, unit margin, with our decision variable. So for the unit margin or profit margin formula, something like this, we need to subtract our cost from our revenue. Our revenue comes from selling price. Our costs include the labor hours for assembly and the cost of components. Part, testing, and assembly. These are the main elements of cost. So now, for this model 1, we want to calculate the unit margin tested on line 1. This one equals selling price, which is going to be the selling price, or B, this one, B13. B13 minus cost per labor hours of assembly times labor hours needed for assembly. B3 times and B9. We are working on the unit margin for line 1, and then minus the other cost element is going to be the hours for testing. This one, B4 times B10. And minus cost of component parts, B12. Okay. This is the unit margin or profit margin for this one. I'm going to copy this one, B3, and then B4. For these constant values, we use $, so the Excel doesn't change their values. Now we can copy this cell for the other elements. We select this cell and then drag it to the end. B3. Okay, that's correct. For the unit margin on line 2, we can write the same formula. We need to subtract cost minus subtract cost from our revenue. Our revenue comes from selling price, that equals B13 minus cost labor hours assembly B3 times labor hours for assembly B9 minus, this time we use cost per labor hours testing on line 2, B5 times B11 and minus cost of component parts minus B12. and then we can drag it across the cells. We got the unit margin, this equation. These two are going to be our decision variables. And we need to define a formula here for the total computers produced. We need to sum these cells. Summation of computer produced on production line 1 and 2. And then drag it to the end of the table. Here we need to calculate our constraints. First constraint is about labor availability for assembling. For labor hours availability for assembling, we have to multiply this one, labor hours for assembly times the total, this one, times total computers produced. So we can use some product of these cells and total computers produced. Labor availability on line 1. You need to multiply this column by this one, total computers produced and total tested on line 1. Again, we use some product of unit margin, here. Labor hours for testing 1 multiplied by the total computers produced. Labor availability for testing on line 2 again equals some product. Line 2, we select this one, times total B21 and 21. Yes. And now here we have to calculate the net profit for the numbers tested on line 1. We need to multiply this cell by the numbers on line 1. This one and number tested on line 1. Unit margin times numbers tested. That equals B14 times number tested on line 1. And we can drag it to the end of the table. And here we calculated sum And the same formula for tested on line 2. Net profit is calculated by multiplying numbers tested on line 2 by numbers unit margin tested on line 2 by numbers tested on line 2. This one. Again, sum, we get the summation, and the net profit is going to be the sum of these two values. So we first identified our variables: constraint, input, decision, and objective variable. Through these formulas, we try to connect our constraint and our objective with the decision variable. And now we want to give this information to the solver. Solver needs to find the best values for these two rows for our decision variable. And one thing is that we can, when we have many variables, we can define name for that range. For example, for the hours used, instead of just saying B25, B26, B27, we can select these variables and go to formula, create from selection. Top row is the title of the row, values are the rest. This is the OK. This is going to be the hours used, hours available. And this one is going to be let's read. And we have this decision variable, number tested on line 1, create from selection. Left column is going to be the name of the variable, and the same for this one. Create from selection. We define name for this range. And we have the next constraint is the total number of computers produced. It must be less than or equal to the maximum sales. We define range name for this range. And from the name manager, you can see the names defined for the ranges. Hours available, hours used, maximum sale, maximum numbers, etc. These are all about the constraints. We can define a new variable for the objective, which is our total. We define new variable total. It refers to J33. So we have these variables defined. Now we can go to data and run solver. Here we can define our variables. Total is our objective variable. We have two decision variables, number tested on line 1, number underline tested. For each space in Excel, you need to put underline in your solver. Number tested, underline, on, underline. Step. Again. Number tested on line under line 1. The second decision variable is going to be the number underline tested on line 2. These are the two variables. We want to maximize the objective. Here we can define our constraints. The first constraint is that hours used must be less than or equal to hours available. Hours underline used must be less than or equal to hours available. We click add. The second constraint is for this one, for total computers produced must be less than or equal to the maximum sales. Total underline computers produced must be less than or equal to maximum sales. Maximum underline sales. Add. Now we can go to our model. We have defined the objective variable, which is total. We want to maximize it. We have two decision variables. I hope I've spelled them correctly. Number tested. And we have two constraints. Here we need to check this box to define the non-negativity constraint. And we select simplex linear programming model. And we want to see what values solver finds for these two variables, these two decision variables, number tested on line 1 and number tested on line 2. Okay. Answer and sensitivity analysis. These are the values that the solver finds. With these values, we can reach the maximum profit of $3,650. That's how we develop and run an optimization model.